So welcome students. So in this question you're given an equation sine inverse of root x plus cos inverse of root of x square minus 1 plus tan inverse of tan y is equal to a. So if this equation has to have at least one solution, how many possible integral values of a are there? So this is an equation in terms of both x and y. So if this equation has to have a solution, so what are the conditions that we have on x and y? So as you can see, this sine inverse x plus cos inverse of root of x square minus 1 is a special combination. So as you can see, if cos inverse of this root of x square minus 1 has to be defined, x square minus 1 has to be at least greater than or equal to 0, greater than or equal to 0, and less than or equal to 1 also, because if this number is greater than 1, cos inverse will not be defined. So x square should be in between 1 and 2. X square should be in between 1 and 2. That means on the positive side, x has to be in between 1 and root 2 on the positive side. On the negative side, x can be in between minus root 2 to minus 1. So these are the two options for x. But let us look at this sine inverse of root x. So sine inverse of root x, when will this be defined? This will be defined only when x has to be positive, because x is inside the square root. So x has to be greater than or equal to 0, but less than or equal to 1, because if x is more than 1, sine inverse root x will not be defined. So for this to be defined, it has to be in between 0 and 1. For the second term to be defined, x has to be in between 1 and root 2. So if both have to be defined, so x can take only one value, which is 1. There is only one common value between these two. So the domain of this combination is a singleton set 1. So this expression will be defined only for x is equal to 1, both of them. And when x is equal to 1, this expression is sine inverse of 1 plus cos inverse of 0. Sine inverse of 1 plus cos inverse of 1 minus 1 is 0. So sine inverse of 1 plus cos inverse of 0 plus tan inverse of tan y is equal to a. So what is sine inverse of 1? Pi by 2. Cos inverse of 0 is also equal to pi by 2. So this combines to get a pi. So tan inverse of tan y has to be equal to a minus pi. A minus pi. And now what is the, if this y has to have a solution, so obviously this a minus pi has to belong to the range of tan inverse of tan y. A minus pi has to belong to the range of tan inverse of tan y. So what is the range of tan inverse of tan y? So how does the graph of tan inverse of tan y look like? So it goes from minus pi by 2 to pi by 2. So it goes like this. It is a discontinuous function. So tan inverse of tan y goes like this. What is the range of tan inverse of tan y? Minus pi by 2 to pi by 2. So if this equation has to have a real solution, then a minus pi also should belong to this range. Then only it gets some value of y. So for this to have at least one solution, a minus pi has to be in between minus pi by 2 and plus pi by 2. Now if you take pi onto this side, this implies a has to be in between. So if I add pi, so you get pi by 2 to 3 pi by 2. So my a has to be in between pi by 2 and 3 pi by 2. That is, a has to be in between, this is pi by 2 is 1.57 approximately, and 3 pi by 2 is 3 times this, 4.71, so on. So my a has to be in between 1.57 and 4.71. So in the question, how many integral values of a are possible? So what are the integral values of a which lies between them? 2, 3 and 4. 2, 3 and 4. You don't have 5 or you don't have 1. So you have to start from 2, 3 and 4. So the integral values of a which are possible are 2, 3 and 4. So how many integral solutions are there? 3 is the answer to this question. Thank you.